So, hello students, we are going to discuss the JEE questions, right? So, let us start. This is the paper of 2nd January morning shift. Okay, so let us start these questions. A solid sphere of mass 5 kg and radius 10 centimeter is kept in contact with another solid sphere of mass 10 kg and radius 20 centimeter. The moment of inertia of this pair of spheres about the tangent passing through the point of contact. So this question is related to rotational dynamics, right? So calculation of moment of inertia. So let us quickly think about it. So there is a sphere of 5 kg, radius is 10 centimeter, right? So there is a small sphere, you can say, and there is a big sphere like this. They are touching each other at this point of contact, and we have to calculate moment of inertia of this pair about the tangent through the point of contact. So tangent, let us take like this. So this tangent we have to calculate moment of inertia, right? So we already know the formula for moment of inertia about this, right? This axis. Similarly for this one, we also know this one, right? So moment of inertia about the center axis, center of mass axis, which is nothing but the diameter. We know that, right? So let us say that this radius is r1 and this mass is m1, and let's say this mass is m2 and this radius is r2. So I about this axis we have to calculate, right? So we need to simply add the moment of inertia of the first sphere with respect to this axis. Similarly for this, with respect to this axis, we can simply add because it is a like a scalar quantity, not exactly scalar, but it behaves like a scalar quantities. We can add them simply, right? But particularly moment of inertia is a tensor quantities because it depends also on the orientation of the axis, right? So let us do that. So this for I will be what? So I1 let us calculate first for this one about this axis. So I center of mass, which is nothing but 2 by 5 mr square, right? 2 by 5 m1 r1 square plus m into distance square, right? So m1 into distance, this is nothing but r1 square. So basically we are supposed to know that this is going to be 7 by 5 m1 r1 square. Similarly I2 also we will calculate. So I2 will come same manner. I2 will come how much? This will also become 7 by 5 m2 r2 square, and simply we have to add them. So let us quickly do that. Let us add them. I is equal to I1 plus I2. How much it will become? 7 by 5 you can take common, right? 7 by 5 let us take common. Then what about the masses? How much is mass? M into r square, so 5 into 10 square, right? So this is going to be 5 into 10 square. Remember this is in centimeters, so this is going to give a centimeter square terms. We have to keep that in meter square, right? We'll convert them. Now this one m into r square, so mass is 10 kg and 20 square, so 10 into 20 square, right? And finally we have to convert centimeter square into meter square, so 10 to the power minus 4 we have to multiply. Now do the calculation. How can we do the calculation? First we can cancel out this 5 with 5 and this 5 with 2, right? So and 10 square you can take out. So what will be the answer? 10 square you take out. So this is 1, 2 and 2 square 4, 4 into 2 8, 8 plus 1 9, right? This is going to give us 9. Then 10 to the power 2 factor is going here. So 10 to the power 2 and 10 power minus 4, that will become 10 power minus 2. So how much? 7 into 9, 63, 0.63. 0.63 should be the answer. Answer should be option number 4. Clear? Right? So I hope you got this idea. Let us move to the next question. Okay, let us go to the next question. 7.9 million electron volt. 7.9 million electron volt. Alpha particle, this is alpha particle, scatters from a target material of atomic number 79. Atomic number is 79. From the given data, the estimated diameter of nuclei of the target material is, we have to calculate diameter of the nucleus. Diameter of the nucleus means what? So suppose that this is the atom, right? This is the atom. This is the nucleus, and let us consider that this is the radius, right? Let us consider that this is the radius. We have to calculate diameter, that means 2 times of the radius, correct? Diameter we have to calculate. So alpha particles is being targeted towards this. Assume that alpha particle is targeted toward the center, toward the center, right? So what happens? It is scattered, right? And what is the atomic number? Z. So charge of the nucleus will be Z into E. You know that. So Z is equal to 79 here. They have given this, okay? And this alpha particle kinetic energy of this is 7.9 million electron volt. This is going to hit that, right? From this information we have to find out this. So first of all, what we can do is, let us say that this alpha particle is coming, and from there it will bounce. From here only scattering will happen, right? So this you can consider as the distance of the closest approach. So let us calculate this distance, which is nothing but radius. This radius is distance of closest approach. So you know that this kinetic energy is going to convert into potential energy, right? Because it will stop here. So here whatever energy is total is kinetic energy, because potential energy is 0, because distance is infinity, right? So initially the separation is infinity. You can consider the distance as infinity. So that's why the potential energy is 0, only total energy is due to kinetic energy, which will convert into potential energy, because here it will stop, right? Then it will turn back. So what is the potential energy? K Q1 Q2, charge of alpha particle is plus 2e, right? So 2e into ZE, K Q1 Q2 by R, okay. Now you have to solve it. Let us quickly solve it. So R you bring this side, and K is nothing but 9 into 10 to the power 9, right? And this is 2 E Z is 79, and this is E divided by this one, 7.9 million electron volt. Million means 10 to the power 6, electron volt means C. Now simplify this. Let us quickly cancel out EE, right? And this also you can remove this, one extra 10 will come here, right? And 79 will go away. So what are we left with? 79 is gone, right? So we are left with 2 into 9, 18 into E. E is also there. E is how much? 1.6 into 10 to the power minus 19, right? That is E. So this 79 I am cancelling here, right? Then what else is remaining? 10 to the power 9 is there, also 10 power 1 is extra there, 10 to the power 10, so plus 10, add powers, and here this plus 6 power will go here, it will become minus 6 powers. So try to calculate this, how much it is going to come. Calculate this. So this is going to be 18 into 1.6 into 10 to the power how much? So minus 19 plus 10, that means minus 9, minus 9 minus 6 minus 15, correct? Now here this you solve. 18 into 16, you do multiplication and solve quickly. 18 into 16, 24, 84, 18, 4, 6, 264. 264 factor is coming, right? Am I clear? 8 into 6, 48. 4 factor will come. 108 will come here. 108. So that will become, this become 108, and this become 18. So 288 factor will come, right? So 288 into 10 to the power here minus 16 you can take, so point here you can take minus 14. right? Minus 14. 10 to the power minus 14, correct? 2.88. So option number third option is the correct answer. Yes, so let us move to the next question. Question number 3. 6-point charges are kept at 60 degree apart from each other on the circumference of a circle of radius r. Then the net electric field at the center of the circle. We have to find the net electric field at the center. So here you want to calculate. How can you do that? So note that this plus q and this plus q, their effect at the center will cancel out. So remove this. This you can remove. Okay. What about this? This plus q and this plus q, that effect at the center will also go away. So this you can also remove. Now what is remaining? Here minus q and plus q. That is what it is remaining. Here minus q and plus q is remaining. So note that what we can do is this minus q will create a field like this and plus q will also create a field like this. So both the field E can become 2E. So let us just add 2E, 2 times E. And also see the direction. What is the direction? X component is negative, Y component is positive. That also you can check. So this is not possible, right? X here minus is there, X component negative, Y component positive, possibility is there. X component negative, Y component is positive, possibility is there, right? What about this? This is X is negative, positive, so not possible. Now out of second and third we need to choose. So we need to definitely calculate these values. So to electric field formula KQ by R square. So apply that. K is 9 into, or in terms of 4 pi epsilon, 1 by 4 pi epsilon naught, right? 1 by K means 1 by 4 KQ by R square. KQ by R square. What is the distance? R. This distance is how much? This is the radius R. KQ by R square, right? So electric field due to positive is KQ by R square, and 2 times you have to multiply. So this is what it is going to happen. So you are going to get this factor in the denominator, Q by 4. 4 will get cancelled, right? It will become 2 pi epsilon naught R square. Okay, but direction we have to write. Direction is unit vector, right? So unit vector means cos theta I cap, sin theta j cap. So this side, what is that angle? Angle you find out angle. So this is 30 degree, and they are saying each angles are 60 degrees. So this is 60, right? So what will be this angle? 6.60 degree apart from each other on the circumference. So this angle is how much? 30 degree, 60 degree, 60 degree. This will be 30 degree. That angle is 30 degree. So cos 30 degree minus, you have to take minus cos 30 degree root 3 by 2, right? I cap, and this sin 30 degree 1 by 2 j cap. That's all. Now you can take out minus you take out. So how much you will get? And 2 factor will also come out, 4 pi epsilon naught R square. Terms will come root 3 I cap minus j cap. Correct? So we got this answer. Second answer is the correct answer. Let us move to the next. Question number 4. XPYQ is a vertical smooth long loop having a total resistance R. Okay, so this is a loop and here resistance is given R. PX is a parallel to QY. So PX means this PX. I think here this is PX and this is QY. Okay, QY. Right, what is the question? Length is L, constant magnetic field is perpendicular to the plane of the loop, exists in the entire space. A rod CD, okay, sliding. Length L is greater than L and mass M is made to slide down from rest under gravity as shown. Terminal speed acquired by the rod is. So what is going to happen in this? Let us try to think about it. So this is a rod like this, and this rod is sliding over a wire frame like this. Okay, the length of this is L, right, and magnetic field is there. Let us take any direction of magnetic field, but definitely the magnetic force has to act upward, and this mg must act downward, because they are saying that it attains equilibrium. Equilibrium means they must, forces must balance, right? So anyway, you don't have to bother about which direction magnetic field is there, but magnetic force must be upward. Then you can think about it, which direction it is. But yeah, of course it is going downward with a velocity v, so it will be going with a constant velocity. Terminal velocity means that only. Terminal velocity means it is going to attain equilibrium, constant velocity. So we need to find out that. Okay. So what happened? You need to just do what? Forces equal the forces. Magnetic force is equal to mg, and magnetic force is what? Magnetic forces, but here charge is not there. So let us say some current will be there. Current, why? Because as this is going down, right, there will be EMF induced. So let us say some current is there. So force is ILB, you can use ILB into mg, and current is what? Current, what we can write? Current is, we can write as voltage by resistance. So voltage developed will be BVL, correct? BVL. So this will be BVL, right? Voltage divided by resistance into L into B into mg. That's also from here we can calculate this velocity v only we need to calculate. So v will become what? mgr divided by L square B square, correct? L square B square. This is what is the terminal velocity. So let us check out the answer. L square B square, this is the answer number 4, right? Fine, so let us move to the next question. Question number 5. The escape velocity from a spherical planet A is 10 km per second. The escape velocity from another planet B whose density and radius are 10% of those of planet A is. Okay. So let us think about it, what they are asking. So they are talking about escape velocity, they are comparing, right, two planets, and escape velocity, they are saying that radius is 10% of the 10% radius. So escape velocity, let us write escape velocity formula. Escape velocity is root under 2 gm by radius, right? This is the formula for escape velocity. So escape velocity from another planet whose density, okay, so they are asking in terms of density and radius. So we need to convert this formula in terms of density and radius. So let us write mass as density into volume. So 2g by radius, mass can be written as density into volume. Volume is 4 by 3 pi r cube. 4 by 3 pi r cube. So this become r square. R square will come out of the root. So you can say that the escape velocity is proportional to, let us write proportionality. So proportional to what? R will come out, and root under density. First of all, you need to think in this way if you want to do fast calculation. Now let us do that. What they are saying, that escape velocity of first planet is given 10. Escape velocity from other planet whose density and radius are 10% of those of. So density and radius both are 10%. What does that mean? 10% means what? 10% means radius is going to be 10% of this, means what? 10% means 0.1. 0.1 times r. That means 10% of that. It is not that 10% increase. There can be a confusion, right? Radius are 10% of that. 10% means it is a smaller of that. Okay, and similarly this density is also 10%. This means 0.1 times rho. So you need to change this 0.1, 0.1. So what will be escape velocity will change. Now escape velocity will become 0.1 under root 0.1. Correct? Yes, check out this. So we are going to get this many times it will become. This many times it will become. So just do the calculation, right? Calculation we have to do, and we have to convert in meter per second. Note that. So first of all, think about it, what will happen. Let us do the calculation here. So this escape velocity will be 0.1, that means 10 to the power 10 to the power minus 1, and this is root under 10 to the power minus 1, that means root 10. You can say that. Let us write this like this. This is 1 by 10 and this is 1 by root 10, correct? And that is 10 kilometer per second. Kilometer means 1000 will multiply, right? That will become meter per second. Let us do this calculation. So this 10 we can cancel out definitely. So 1000 by root 10, which we can write as 100 root 10. Clear? Check out the answer, 100 root 10. So they did not give in decimal, otherwise we have to do calculation. We can save time because options are like that. Okay, let us move next. Question number 6. A meter bridge with two resistance R1, R2 are shown. Okay, balanced at 40 centimeter from this point left side, and the null point changed to 50 centimeters from the point P when 16 ohm resistance is connected in parallel to R2. So this R2 is getting modified. Because of modification of R2, this null point length is changing, right? Okay, so what we need to do? The value of resistance R1, R2. R1, R2 we have to calculate. R1, R2 we have to calculate. And you can see that R2 is, all R2 values are different, or all R1 values are different. Any one you calculate, done. We are done. If you can calculate any one of them. So let's target to calculate any one, right? Okay, so what you have to do? So first of all, what is that ratio? Initially it is balanced, right? So R1 by R2, this is balanced at what? 40 centimeter, right? 40 centimeter. That means this is 40 and remaining 40. This is 40, that is remaining 100 minus 40. That means 60. So 40 by 60 it is. 40 by 60 you can write as 2 by 3. Correct? 2 by 3. We know this. Now next, they are applying some parallel in R2. How much parallel they are applying? 16 ohm. 16 ohm is applying parallel. So what will be ratio now then? R1 by, that will become what? R2 into 16 divided by R2 plus 16. Right? And what will be this ratio now? They are saying how much it is? Null point changed to 50. Null point has changed to 50 means 50-50. 50-50 means ratio is 1:1. 1 it will become. So from here what you can do is, definitely you can very easily substitute this R1 by R2 value as 2 by 3. So substitute this as 2 by 3. Then game is over, right? Okay. Solve it now. Over. I think R2 you are able to calculate first. Okay. So how much will be R2 from here? Calculate R2. So this is going to be 2, you cancel out, this is 16, 8 into 3, 24, right? 24 it will become. And 24 minus 16. 24 minus 16 is how much? 24 minus 16. Is it 8? 8. So this is the answer. You don't have to calculate R1. Fine. Let us move next. A projectile is thrown upward at an angle of 60 degrees with the horizontal. The speed of the projectile is 20 meters per second when its direction of motion is 45 degrees with the horizontal. The initial speed of projectile is. Let's quickly try to draw the diagram. What is happening? A projectile is thrown, right, at an angle of 60 degree. 60 degree, and its initial velocity not given. Okay, u is initial velocity. They are saying that velocity of projectile is 20 meter per second when its direction is 45 degree. That means at some instant, let us say some instant, it is making 45 degree. You know the angle is going to decrease, so it is making 45 degree. That time speed they have given as 20 meter per second. They are asking what is the initial speed. You have to calculate you, so you know what happens in projectile motion, right? The horizontal component always remains same. Vertical only changes due to gravity, right? So horizontal component only you have to equate, that's all. So here this is u cos theta, u by 2, and here this is 20 cos 20 by root 2. So that's all over. So equate both of them. So u by 2 is equal to 20 by root 2. Correct. So this u comes out as 40 by root 2, which you can write as 20 root 2. Correct. 20 root 2, that means option number 4. Fine. So let us move to the next question. Question number 8. Given below are two statements. Statement 1. Pressure of the fluid is exerted only on solid surface in contact, as the fluid pressure does not exist everywhere in a still fluid. That itself is wrong. Fluid pressure will be there at different point. We have different pressure, right? Rho gh, hydrostatic pressure. So first statement itself is wrong. This is wrong. Okay, next. So you choose, we'll choose that. Next, what they are saying, excess potential energy of the molecule on the surface of a liquid when compared to interior results in surface tension. So we know that molecule at the surface has excess energy, right? Because it is unbalanced. So because of that, there is surface tension effect, right? So this statement is correct. This statement is correct. Now what we need to choose? Let us see that. First is wrong. Statement first is wrong. Statement second is correct. So statement first is wrong. Second, fourth, option number 4. Yes, this is what we can choose. Let us move next. Find the correct combination of A, B, C, D inputs which can cause the LED to glow. This question we have to understand. LED to glow. Where is LED? We have to see in the circuit. This is LED. So this LED is a device which will glow when current will pass through it, right? So current pass through it means what? So if current has to pass, this forward bias only current will pass, right? So current has to go this way. That means this must be higher potential and this must be lower potential. So we have to make sure that here higher potential should come and here lower potential. And in binary numbers, 0 means low value and 1 means high value, right? So 1 means here we should get here 1 and here we should get a 0. So 1 should be the output of this upper branch and 0 should be output of the lower branch. Okay. So we can think about it. Okay. So I think looking here it may be better, because suppose C and D you are giving as input and there is a this is what, this is OR, right, OR gate, and there also this is there. That means it is a NOR gate. So what is the output of NOR gate? You can think about it. And here we should get 0 0. First make CD. What are the values of CD? CD can be 0 0 0 1 1 0 1 1. Now here let us take OR. If you apply OR gate, what happens in OR? So if any one of them is 1, then it will be 1. This will be 0. All other cases will be 1. But what about NOR? If I want to write NOR, output of NOR means it will negate. So it will become 1 0 0 0. So we want here 0. So 0 means these are the possibilities. Correct? 0 0 0 means these are the possibilities. So 0 0 0 means C and D can be either this or this or this. Now check out the option. C and D we have to think of. 0 1. 0 0 is not possible, so this is gone. C and D cannot be 0 0. 1 1 may be possible, 0 1 possible, 0 0 not possible. So you can reject two options. Now out of these you cannot still guess. You can guess, but the thing is that you need to think about that A and B also. Okay, let us think of A and B now. So let us make for A and B and do that. Okay. Now I will make for A and B. A and B. Again, A and B can be 0 0 0 1 1 0 1 1. And here output you need to see what it is. So here A is going A and this is OR. NOR. Again this is NOR. NOR means again this will just reverse. That means this is A bar basically, and this is also B bar, and both of them, this is and then this is NAND. Okay, so NAND operation means what? What is NAND operation? So first of all, A bar dot B bar. This is AND operation, right? And over that also bar. So what it will come here? We can say A bar bar. A bar bar will go away, plus B bar bar will go away. So that means output is just A plus B. That's all. A plus B, you think about it. What is A plus B? A plus B means plus only, right? Plus means OR operation. So OR means again this can be like 1 1 1, but we have to make it A plus B. So this is the output, right? This is the output. I think we have got the output here. So A plus B we have got. Now in this A plus B we need to get the output as 1. So which one is 1? These are the three possibilities: 0 1 1 0 1 1. Check out which can match here. So 0 0 will not match, so definitely this is also gone. So we have option number 4, right? So that's how we can do it. Let us move fast. Next, question number 10. Net gravitational force at the center of a square is found to be F1 when 4 particles having mass m, 2m, 3m and 4m are placed. So here some masses are arranged, right? And they are talking at the center. Center means I think they must be talking of the field, because they have not kept any mass there. So I think they are asking of the field there. Okay, so field that is given F1 having mass is this. Okay, and it is F2 when the positions of 3m and 4m are interchanged. So suppose if you interchange 3m and 4m, then it becomes F2. Okay, then question is the ratio of F1 F2 ratios they have given. So first think of F1 calculation. So field calculation we have to do, right? So what happens here? These distances are all equal, right? All the distances are equal. So this is 2m here. Note that this is 2m here. This is 2m here. So this 2m and this 4m we can write as 2m. So the effectively you can say that instead of this 4m 2m, you can simply write 1 2m at this corner, right? You will be able to write a 2m at this corner, because this 4m and 2m effect will be, this 2m effect can be neutralized by this 4m, and effective 2m will be remaining. Okay, so effectively 2m will be there here. Okay, then similarly here m and 3m, so this m you can subtract here. So effectively here there will be, how much will be remaining? So 2m will be remaining here. Right now, due to this, at this point, let us consider that this field is E, or let us write this as F. Okay, or this is F. F is nothing but the field. Okay, so and this is 90 degree. So F at 90 degree will become root 2 F. Root 2 F. This I am going to write as F1, and F is due to 2m. So this root 2 into, it is proportional to that mass, right? So 2m, G also will be there, right? So let us write this as proportionality. So F1 will be proportional to this. Now similarly, what is going to happen if you interchange? If you interchange, here 3m will come and here 2m will be coming, correct? If you interchange that, let us say you interchange, now 3m will be coming here and here 4m will be coming. Now the effective opposite you are seeing. So this is 3m, this is 2m. So 2m you subtract from 3m, only m is remaining. So now only m is remaining. What about this side? Now there is 4m here and this is m. So m you subtract from 4m. So then you will get only 3m. So now we have 3m. Okay, so now what will be the field? Okay, field due to this will be how much? And we have to again add root under. So this F2 will be what? Resultant of these two. How much it will be? So Gm by R square, right? So m, it is proportional to m by R square. Let us write Gm by R square. And here how much will be? G into 3m by r square, because distances are same. So when you are going to add this root under this and this, let us write only proportionality. So F2 will be proportional to what? Root under, this is 1 and 3, right? So root under 1 square plus 3 square. So root under 1 square plus 3 square. 1 square plus 3 square. And factor m will be coming out. Correct. So how much will be? This will be root. This will be how much? Root under 10. 10. Now you take the ratios. So let us take ratios. F1 by F2. F1 by F2 ratio, when you take, what do you get now? 2 root 2. This is 2 root 2. And here root under 10. So how much this will come? 2 by root 5. Correct? 2 by root 5. This is what is the ratio getting, 2 by root 5. So definitely this alpha must be 2. This alpha must be 2. So let us choose the answer. So correct answer is first, option 1. Clear? Let us move to the next question. The minimum frequency of photon required to break a particle of mass. This particle mass is given in AMU into 4 alpha particles is. Okay, so this question is of nuclear reaction, right? So nuclear reaction is happening, right? And it is becoming 4 alpha particles, minimum energy of radiation required to. So let us say that there is a nucleus which is breaking into 4 alpha particles. So there will be changes of energy, right? So mass effect will be there, and you can calculate that energy. That energy is what is required, correct? So that energy we can calculate. How do you calculate mass effect? We can calculate this, right? And energy we have to get this in terms of what? Values of energy is in, sorry, frequency we have to calculate. Frequency we have to calculate. So first you calculate energy, and that energy of the radiation can be converted into frequency, right? How to approach that? Let us first calculate energy. E is equal to delta m into c square. Delta m first we have to calculate. What is delta m? Delta m is the loss of mass that will happen. 4 alpha particle means helium nucleus it is, and 4 times if you do, how much it will become? It will become 16.008, right? So 16.008 minus this mass which is given, you subtract that. So 15.348. So how much this will come in atomic mass unit? Calculate. So this will be 0. Here 8 0, this 10 minus 4 6, 9 minus 3 6. So 0.6 is basically this 0.6 is same here. We have to substitute that, and energy, this is energy of radiation, which you can write as h into frequency, right? H into frequency you can write. H into frequency is delta m into c square. Now you have to do just pure calculation. Okay, so energy and frequency in kilohertz we want. So calculate frequency. Delta m is 0.66. Okay, and one atomic mass unit is nearly 1.66 into 10 to the power minus 27 into speed of light 3 into 10 to the power 8. They have also given, so just try to square that. So 9 into 10 to the power minus 16, sorry, plus 16, then divided by h. H is what? H is also they have given 6.6 into 10 to the power minus 34. Okay, so let us use this value and calculate. Do calculation. And also note that this has to brought in kilohertz. This is hertz. So you can divide by 10 to the power 3. Now this should be in kilohertz. So do this calculation, how much it will come, and check the answer. Can we cancel out 1.66 nearly to this? Can we cancel out to 4 times approximately? Okay, approximately you calculate. and this you can also cancel out 2 and 0.33. Nearly, well, let us calculate it. So if you take this one frequency, that 33 also you divide it, right? It will become 0.16. Nearly 0.16 you take, multiply with 9, then multiply with powers you check. Powers you check. Definitely 9 terms is not going to come, isn't it? 9 terms will not going to come. Now this term will come, but powers you check, but 14 factor is they have given. Okay. So what about these powers? Powers you calculate. So this is minus 34, minus 31, minus 31 and minus 27. How much it will come? Do this first. So minus 27 and 16. How much it will become? Yes, this will become minus 11. So minus 11 and here minus 31. So 20 it will become, I think. No? Because here it was how much? Minus 11 and this is minus 31. So 31 minus 11. 31 minus 11 is 20, right? And this will give us nearly 144. So 1.44 into 10 to the power 20 nearly will come, and we can see here 14 they have written. So that means what? That means which answer can be correct? 10 to the power 20, you cannot take this one. So can we go with this one? Correct, right? I hope this is clear, right? Because 19 will come, 110 will take, 14.44 will come. So that is the correct answer. Let us move next. Question number 12. A cylindrical tube AB of length L closed at both ends contain ideal gas of 1 mole having molecular weight. Okay, so there is a tube whose end is closed both ends and it is, I think, rotating as in the diagram. It is rotated horizontal plane with constant angular velocity. Omega is constant here. Okay, right, passing through the edge as shown. PA, PB are the pressures at A and B respectively. Then consider temperature at the same. Okay, so I think they are saying pressures at A and B they have given, and we need to get the expression which can be correct. Can we think about rejecting any options? Think about it. Because you should know that as it is rotating, the pressures, see, suppose if I take here at any point, so there must be extra pressure right side because you need a net force toward the center, right? You need a net force toward the center because it has to go in a centripetal acceleration or centripetal force. So this side pressure must be larger than this side pressure. So pressure of the point B should be larger than pressure of point A. Think about it. Can we reject wrong options or what? Definitely this is not going to be correct. Okay. Now pressure of point B. Okay. Exponential power are there. Exponential power. So then we how to do that? I think we need to derive it because these factors we cannot judge, right? We cannot judge it. So how to do that? So you need to take a small element like this way. So let us take a small element of length dx at a distance x from the center, right? And because it is going in a circular motion, so there must be net force, that is centripetal force, and net force will come due to pressure difference. Let us say pressure difference is dp. Dp is pressure difference. So as you are going away, that side pressure is increasing. Okay, so pressure difference into the area, pressure into area, that is the force. Correct. Pressure into area is what? Pressure into area is force. So that is a net force. This force is the centripetal force that we can write as m omega square radius. Mass is a small mass dm, m omega square, because it is rotating angular velocity omega square into radius x. Okay, now we have to think how to solve this differential equation. So how do we write this pressure? How do we write this pressure Tp? So note that PV is equal to nRT, right? So this pressure difference, how can we write this pressure difference? dP. dP, let it be, I think we can think of writing dm then. dm we can write. How can we write dm? So can we write here as mass, small mass in terms of density? Also we know this equation, this Pm is equal to rho RT. In terms of density, this is the ideal gas equation, right? So this dm which we are writing here, this density, small mass is density into volume. Volume of that element will be area into dx, right? And this density we can write from there. So that density we can write as P into m Pm by RT, Pm by RT into A dx. So this is what we are going to substitute dm here. Let us do the substitution and see what do we get. So after you substitute dm, right, so which will come as Pm A dx divided by RT, and this is omega square x is equal to dp into A. So A factor will get cancelled, right? What do we get then? In terms of pressure, we are getting that equation, correct? So what are the equation we are getting in terms of pressure? Let's write that. So we are getting dP divided by P is equal to, dP divided by P is equal to m omega square x dx m omega square x dx by RT. Right. So when you are going to integrate this, right, that will become ln P, and P is going from A to B. So PB by PA, right? PB by PA will come. Lower limit is PA, upper limit is PB, and this will become how much? X integration is x square by 2, and x is going from 0 to L. So m omega square x is L square by 2 RT. Now exponent form you can write it, correct? Write it in exponent form. So what do you get? PB by PA is e per power. So PA into e per power is nothing but exp. Exp means e per power. Okay. So m omega square L square by 2 RT. So that's the answer, I think. First option. First answer. Clear? So this question required derivation. So what JEE is checking is whether you have the ability to derive certain equations or not. And you may stop the calculation here at this step itself. Why? Because you know the factor 2 will come, because when you integrate x, you will get x square by 2. That factor 2 will be in the denominator. You can stop your calculation and move to the next, because you have to save time in the exam, right? Let us go next. Question number 13. Rods X and Y are equal dimension but of different materials. Okay, here all the dimensions are same but materials are different. Okay, temperature of the ends are given. So this is at 100 degrees Celsius and point F is 0. Sorry, 40. This is 40 degrees Celsius. Then given the thermal conductivity rod X is 3 times that of Y. Rod X has 3 times conductivity. Okay. Then temperature at junction points B and E. So we have to calculate temperature of these points B and E. So what should we do here? They have given that condition that thermal conductivity X is 3 times Y. Conductivity X is 3 times Y. So if conductivity is 3 times, then resistivity is 1 by 3 times, correct? Or resistance is 1 by 3 times. So if I consider that, if you want in terms of resistance you can write, or in terms of conductance you can write, anything is okay. But they have given x as 3 times conductivity, given the thermal conductivity x is 3 times of y. Suppose if you take this conductivity as k, then you have to take this as 3k, 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 correct? Now I will write in resistance, because calculation of resistance is like electrical circuit. So I am going to write this as instead of I am using R now. So if I say that it has 3k, conductivity of conductance is 3, so resistance will be 1/3. So if I take this resistance as R, then this resistance will be 3R, 3R, right? 3R. Resistance I am writing, resistance, and this is RR. I am writing in resistance, which will be easy to calculate. Now do the calculation. Okay, so what calculation we can do now? So first of all, this resistance is our 3R, 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 3R in series. 3R, 3R in series will become what? 6R, 6R, and here R will become how much? 2R. So here we have 6R and we have 2R. They are in parallel. What will be their equivalent? So 6 into 2 by 6 plus 2, 8, right? So 2, 4, 2, 2, 2, 3. So we are getting 3 by 2. That means 1.5, 1.5, 1.5 R, correct? So now you can say that this is the resistance of R. This combination is giving a resistance of 1.5 R, and that side is 3R, correct? Right, now total is how much? Calculate total. So 3, 4, 4 plus 1.5, 5.5. So R equivalent you got as 5.5, correct? You got R equivalent. So first of all calculate current I. I is equal to total potential difference is temperature difference. So 100 minus 40 is 60, 60 by resistance, this is 5.5 R. And note that the same current will be passing in this branch or in equivalent branch or this branch. So suppose if I take the same current here, then let us say temperature here is T1 and temperature of E is T2. So here what is this difference? 100 minus T1 divided by 3k, or sorry, this R divided by R. Now solve this. Now solve T1 and then we can check out. So R factor will get cancelled. So we will get as T1 will come as 100 minus 60. You can take 600 by 55. Check out this much. 11 we can cancel. 5, 11 and 5, 1, 2, 120, right? So how much it will come? T1 will be coming as how much? 100 minus 120 by 11, nearly 11 you can say, right? Nearly 11, because 120 can be taken as 121. So 100 minus 11 will be how much? 100 minus 11, 89, correct? 89. So 89 will be the temperature of B. Now just try to match it. 89 will be first option, correct? First option, you got that. Let us move next question. Question number 14. A thin convex lens of focal length 5 cm and a thin concave lens of focal length 4 cm combined together without any gap, and this combination has magnification M1. Keeping the position of convex lens object and disturb a gap of 1 cm introduced between lenses by moving the concave lens away, which lead to change in magnification. Total magnification system M2. So M1 magnification calculation we have to do. So which formula we can use? First, let's draw the diagram. Within convex lens of focal length 5 centimeter and concave lens, these are combined together without a. So initially both the lenses are kept together without any gap. Okay, magnification M1 when a object is placed 10 centimeters. So first there is a convex lens and there is a concave lens. Both are like this. Magnification we have to first calculate the focal length, because magnification formula is what? Magnification is f by f plus u. Can we use this for lenses? Better we can use that. So object, where is the object kept? 10 centimeter before. First you need to calculate the equivalent focal length of this combination. What will be the equivalent focal length? 1 by f equivalent is 1 by f1 plus 1 by f2. Let us do that. 1 by f1. So convex is positive, so 1 by 5 plus concave. Concave is going to be negative, that means 1 by minus 4. So check out this calculation. Let us take 20. If I take this as 20, so 4 minus 5 minus 1, right? So focal length becomes here minus 20. Minus 20. So let us substitute this and check. So focal length is minus 20. This is minus 20. Object is anyway left towards that side. So how much is object distance? Object is how much distance? 10 centimeters. So minus 10. So that will become minus 20 by minus 30. So 2 by 3 it will become. Correct? Right? We got magnification, first magnification. Now they are saying that the lenses are separated by some distance. How much? 1 centimeter. Then what happens to the magnification? Other things are not disturbed, right? Other things are not disturbed. Right? Object and positions of convex lens. Keeping the positions of convex lens and object. Convex lens and object are same. Okay. Concave lens is only moving. Okay. So try to think of the basic here. So what happens is that this convex lens and object is same. Object 10 centimeter, but this concave lens is now separated by 1 centimeter distance. Then they are asking magnification. So we can try to calculate magnification from the first lens first, because final magnification M2 can be taken as magnification due to convex into magnification due to concave. Right? So magnification of this, first you calculate. Magnification of convex you calculate. Magnification of convex. Same formula we can use f by, but f is for this lens. So what is this convex lens? It is 5, right? So f5 by 5 u is minus, right? So minus 10. So how much this becomes? It becomes minus 1. It becomes minus 1. What about this magnification? This you need to know where is the image formed. So first you calculate this image. Image you calculate. So magnification is what? Magnification is v by u. So you already know magnification minus 1, and this is center of curvature, right? So image is also formed at same distance 10 centimeters from this. 10 centimeter it is formed, and it will be inverted, so minus is coming. And here this distance is 1 centimeter. That means from here this will be 9 centimeter. Correct, because from here it is 10 centimeter and this gap is now 1 centimeter. So from concave it is 9 centimeters. Okay. Object, that will act as object, right? Virtual object. So now let us write the magnification formula for this concave. Concave magnification will be what? Same formula, f by f But focal length is what you have to consider, ray going in this way only. Rays are going this way, so this direction is negative. So focal length is anyway negative for this, you know that. So how much is focal length for this? Minus 4. So minus 4 focal length f by f plus u. So f is how much? Minus 4. But now you see u is plus 9 for this. So u you have to take as plus 9. So you will be getting here as minus 4 by 5. Okay, so now you can calculate this magnification m2. So m2 will be how much? Minus 1 into minus 4 by 5. So we are getting this as 4 by 5. So this magnification is 4 by 5 and first magnification was 2 by 3. Now we have to take the ratios. So do that ratio. What is the ratio of m1 by m2? m1 is 2 by 3 and m2 is 4 by 5. 4 by 5. Anyway, magnitude they are asking. So calculate this. So this will become 2. This is going to be 5 by 6. Correct? 5 by 6. We are not getting this answer as 5 by 6. Where the mistake has happened? So magnification formula is f by f plus u. We have used it properly. First case equivalent we have calculated minus 20 and we have used it. Okay, so 2 by 3 was correct. In this case, what we know that this is forming at 10 centimeter and this is forming here 1 centimeter gap is there, so 9 centimeters, right? 9 centimeter it is. So object image distance will be 9 centimeter. This is the image distance which is going to act as an object. So magnification for this will be f by f minus u only. So focal length is how much? Focal length is minus 4 f by f, but the object distance is going to be plus 9. So minus 4 by 5. Okay, so how much it is coming? Both this magnification we have to multiply. If I multiply both this, so here it is minus 1, minus 4 by 5, 4 by 5, 4 by 5 means 5 by 6 we are getting. Okay, we'll check that. Let us move to the next. Question number 15. Consider this. Consider an equilateral prism, refractive index √2. A ray of light is incident on its one surface at a certain angle I. If the emergent ray is found to graze along the other surface, then the angle of reflection. So let's draw quickly the diagram. What they are saying, consider equilateral triangle. So these angles is equilateral means A is 60 degree. Okay, and they are saying that this ray is coming like this. So this ray will be coming somewhere here like this and some incidence angle will be there, right? So here will be the normal, here also will be the normal, right? So what are they asking to calculate? Angle of reflection r1 they are asking to calculate. This is r1 and this is r2 and this angle is 90 degree here. This is 90, correct? This is 90 degree. What is 90? E is 90. I also we do not know. They are asking to calculate, right? R1, so definitely R2 is critical angle. R2 is the critical angle. Critical angle is nothing but sine inverse of 1 by mu. We can use that. What is the value of mu here? Mu is √2. So that means 1 by √2 means 45 degree. So we got this R2. Once you got R2, R1 plus R2 is A. This you know that, right? So R1 will become A minus R2. A is how much? 60. 60 minus 45. That will give us 15. Correct? That's the answer, option 1. Let us move next. Question number 16. The volume of an ideal gas increases 8 times and temperature becomes 1/4. So volume becomes 8 times, temperature become 1/4 times. Okay, during reversible change, if there is no exchange of heat means you have to catch this word, no exchange. No exchange means it is adiabatic. Delta Q is 0. This means it is a adiabatic process. That's all. Once you got this idea, then think about it. What they are asking? Anyway, they have also written it very clearly. Then identify gas from the following option. Assuming gas given in the option of ideal gas. Ideal gas we have to take. Okay, so okay, temperature volume relation T V power gamma minus 1 should be constant, right? So T1 V1 power gamma minus 1, T2 V2 power gamma minus 1. So what will be the ratio of T1 by T2? T1 by T2 ratio is V2 by V1 power gamma minus 1. So let us calculate that quickly. So T1 by T2 is what? This is T1. T1 by T2. So T by 4 will come 4, right? This will become 4. And V2 by V1 means this will become 8. 8 per power gamma minus 1. So now from here you solve it. 4 can be written as T square. 8 can be written as 2 cube. Right? Now you equate that. So 2 is equal to 3 times gamma minus 1. So gamma minus 1 you are getting as 2 by 3. And note that gamma minus 1 is nothing but 2 by degrees of freedom f, right? So from here f is equal to 3. Degrees of freedom 3 means what? It is a monoatomic gas, correct? Monoatomic gas has 3 degrees of freedom. So option is helium. Fine, let us move to the next. Question number 17. Electric field in a region is given as A, B are given, then electric potential at a point is. So what is given? Let's write first clearly. Put the values itself now. So electric field is A is given as 10, and note that everything in SI unit it is 10 xi cap plus 5 yj cap. This is what is electric field in vector quantity. Okay, if the electric potential at point, so there is a point here 10 comma 20. Here the value of potential is given as 500, and they are asking at origin. Origin means 0 comma 0. What is potential here? That is the question. So what you can do is you can go from either here to here or here. Anyway, you can move. Let us say I go from origin to this. So you know this, that delta V is minus E dot dr or delta R. We can write like this because here field is constant or variable. Field is variable. So we cannot write like this. Here we have to write integration dot dr, correct? Let us do this calculation. And delta V means final minus ratio. So I can write this as 500 minus V. That is going to be minus. Now integration of this dr, you know, dr is nothing but what is dr vector? Dr vector is dx I cap plus dy j cap. So let us take dot product and integrate. So 10x dx, this will become 10x dx, and this will become 5y dy, right? This you have to integrate. So let us integrate this. Minus, if you want, we bring this side. So this become v minus 500, and this become 10 x integration x square by 2, y integration is y square by 2, and the values of x and y are going from origin to that point. So initial value you can substitute 0 0, which will make everything 0. Upper limit is 10 comma 20, 10 comma 20. So substitute only the upper limit. You want to substitute only upper limit, right? Substitute. So v you can take also 500 that side plus. So this will come 5 times x square. X square means 10 square, 10 square, right? And this is 5 by 2, y square, 20 square. So check out this calculation, how much it will come. So v will become equal to 500 plus 10 square, I will take common. 5 into 10 square I will take common. That means 500 I will take common. So 1 plus this 2 square become 4. 4 by 2 is 2. So this is going to be 3. So this become 1500. 1500 plus 500, 2000. 2000. Yes. So the correct answer is option number 3. Clear? Right. Let us move to the next. Question number 18. A simple pendulum has a bob with mass m and charge q. The pendulum string has negligible mass. When a uniform and horizontal electric field E is applied, the tension in the string changes. The final tension in the string when pendulum attention equilibrium position is. So this is also a very important result. Suppose right now this is pendulum is hanging. As soon as you apply a electric field and this has got some charge, right? It has got some mass and some charge. String does not have anything, any mass. So once you apply electric field, so you know that electric field will push it this direction. So this string will become like this, and this is Q into E. The electric force will be acting. Mg will be acting downward, right? Now, previous year already they have asked this angle. They are not asking that angle. They are asking here final tension. This tension they are asking. So you know that this tension has to balance this sum of resultant of this, and they are at 90 degrees. So simply resultant of this is what? Root under QE whole square plus mg whole square, right? Because they are perpendicular. So this is what the tension will be. Check out. So option number 3. Clear? Right. Let us move to the next. Question number 19. Choose the correct answer from the options given below. So whenever these type of questions come, you have to be selectively choose such option which can give you fast answer. Right. So which one should we check? Second, first. Answers are not repeating, right? So let us start with any one. A, let us check with A. Spring constant. You know, spring constant force F is equal to minus kx, right? Anyway, k dimension will be force by x, right? Dimension of k. Force is ml t minus 2 divided by l. So that means mt minus 2. Mt minus 2 must match. So mt L0, L is 0. So this will match. First we'll go with second. So you are done off with second and third option. So either this. Now we can match B or C. B or C, anything you match, whichever is easier. Whichever is easier for you, you match that. If I take C, it will be easier because Boltzmann constant means PV is equal to NKT, right? This K is what we have to calculate. Dimension. PV is nothing but work. We already know PV is nothing but work. So K dimension of K will be coming as work divided by temperature. Work by temperature you calculate. Work is ml square T minus 2, right, divided by temperature. So that you can directly match with this one, right? So C is going to match with, C will be matching with first. C should match with first. So this option, sorry, C should match with first. This option, C is first, right? Option number 4. Correct. Let us move to the next question. Three identical coils C1, C2, C3 are closely placed such that they share a common axis. C2 is exactly middle. C1 is having current I in anti-clockwise. C3 is carrying in clockwise, same amount of current. Induced current flows through C2 will be in clockwise direction when. So see, in this question they are saying that 3 wires are there. This wire means it's a coil, not wire, coil, and they are equal distances and they have same axis. Axis is same. So this is C1, let us say this is C2 and this is C3, right? C2 is exactly in between. They are saying that in this coil 1 current is anti-clockwise. In this current is anti-clockwise and this current is clockwise. Same current is there. Now they are saying in induced current flows in C2 clockwise direction. You want induced current in clockwise direction. Note that you want in clockwise direction. Clockwise direction means what? You want in the same way as C3, right? So for that, what we have to do, we have to check with the options. Let us check with the option. C1 and C3 move with equal speed away from C2. C1 and C3 equal. Suppose if you are moving equal speed, so what will happen in that case? Think about it. If they are moving opposite direction, so what will happen with that? Think about it. Suppose if you are moving this, so right now, let us say this is anti-clockwise. So anti-clockwise means field will be passing through this way. Here, field due to this will be passing through this way. And what about this one? This is clockwise, so field due to this will be passing through this way. So anyway, both the fields are going to cancel out because they are equal distance, so nothing will happen. Nothing will happen with this. Okay, so equal speed, if you move, nothing will happen. So you can leave that. C1 C1 moves towards C2. C1 moves towards C2 and C3 moves away from C2. Suppose this moves towards and this moves away. So if this moves towards, what will happen? So it is creating this way. So this is going to increase, and if this is going to increase, this is going away, so it will this side will be decreasing. So resultant this direction it will increase, and if this direction it is increasing, so it will be giving, it will be trying to oppose that. So as this is increasing, it will try to oppose that. So to oppose that, what it will do? It will produce clockwise. Correct? It should produce clockwise. So what they are asking, to produce clockwise or anti-clockwise? Clockwise. So we can choose this. Yes, we can choose second option, right? Here you need to check each of them and then you can think about it. Let us move next. That was application of Lenz law, right? Question number 21. Two loudspeaker L1 L2 are placed with a separation of 10 meter as shown. Figure is also given. Both speakers are fed with an audio input signal of same frequency with constant volume. Okay, a voice recorder initially at point A at equidistance to both loudspeaker is moved by 20 meters along the line AB while monitoring the audio signal. The measured signal was found to undergo 10 cycles of minima maxima during movement. The frequency of the inputs in, first of all, the question is lengthy, right? You have to properly read with patience. Two loudspeaker L1 L2 are placed with a separation of 10 meters as shown. Where is the diagram? This is the diagram. These two loudspeaker L1 L2 10 meters from this, right? Then what? Then both speakers are fed with an audio input signal of same frequency with constant volume. So both of them have same frequency. So you don't think about beat then. If they have same frequency, beat will not be produced. That means there is superposition in space you are going to consider. Not superposition not in time, but superposition in space. Okay, and they have constant volume. If voice recorded initially at point A at equidistance to both loudspeakers. So there is a recorder which is equidistance, right? Initially at A, it is moved 25 along the line AB while monitoring audio signal. The measured signal was found to undergo 10 cycles. So now here see this is moving in this way and it is going how much distance it is moving. Let's first see that 25 meter it is moving and 10 cycle of maximum minima. So this is 25 meter here, note that this is 25. Then it is 10 signal of maximum minima happens. So that means 10 maximum minima you can consider. Okay, so how will you think about it? And what they are asking to calculate frequency of the input. We have to calculate frequency of this signal. So how to calculate first? Think about it. So suppose we have moved the distance of this 25 which they have given. So what is the path difference you can consider? So this path difference you need to calculate. Okay. So think about it. This is total distance. So this will be 5 above, 5 below, right? And this is 40. This is 40. So this is also 5, correct? So this 25 plus 5 is 30, 30 plus 40 perpendicular, right? So this will give us 50. So this is going to get us 50. What about this length, this hypotenuse? So for that you check this one. This is 40, this is 40, and this is 25 minus 5, so that is 20. This is 20, so this will be root under 20 square plus 40 square. 40 can be written as 2 into 20, so 20 square can be taken out, so 20 root 5, correct? 20 root 5, right? 40 square is 20 into 2 whole square, 20 square take 20, right? So these are the two distances. And what will be the path difference now? Calculate path difference. Path difference delta x I want to calculate. So this path difference 20 root 5 and 50, 20 root 5. So which will be larger? Root 5 is how much? Did they give the value in the question? 2.23. Okay, so 2.23. So 20 root 5 is how much? 20 root 5 is 20 into 2.23. Okay, you can calculate this. So this will be how much? But 50 is larger, so part difference is 50 minus 20 root 5. Let us try to do this calculation. So we need to do this calculation, right? So how much this will come? Let us check that. So 100, if I multiply this, so this become 44.6. So 50 minus 44.6 is how much this part difference? Calculate. So it is 5.4, correct? 5.4, yes. So 5.4 units are meter only. I think units are all meter. Okay, so part difference is you got. So part difference should be what? What should be the path difference? Yes. For maximum minima, n lambda we can use n lambda. Path difference you can use n lambda, and they are saying that it is how many maximum minima? How many cycles are there? 10 cycle, 10. So n you can take as 10, and you can take and speed is 324. So n you can take as 10. 10 lambda is 5.4. So lambda becomes 0.54 meters. Now frequency is equal to speed by lambda. Speed is 324 divided by 0.54. Check out this calculation. 100 factor will come. Will it get cancelled? 54. You have removed this decimal. This decimal is removed, right? So if I multiply with 6 factor, it is getting cancelled, right? So you got the frequency as 600. Clear? 600 hertz, that is the answer. Let us move to the next. Question number 22. The electric field of a plane electromagnetic wave traveling in an unknown non-magnetic medium is given by. So electric field component is given. The dielectric constant of the medium h. Speed of light is in free space is given. The electric field of a plane electromagnetic wave traveling in unknown non-magnetic medium is given by. So what happens is that here what is given here, electric field is given. Electric field is given as 20 sine of, this is nothing but kx, right, minus omega t. So from here you can definitely see this is the amplitude. We need to calculate dielectric constant. So what is the speed? We can calculate first. Speed is equal to omega by k. Let us find out what is omega by k. And you should know that the speed of light is how much in vacuum by refractive index, which is root under mu r epsilon r. This formula we know, and they are asking dielectric constant means epsilon r. Mu r should be taken as 1. Why mu r should be taken as 1? Because this is non-magnetic. non-magnetic medium. For non-magnetic medium, we can take mu r as 1. So that means you will get epsilon r as c by v whole square. So just calculate this c by v. So v you calculate omega by k. Omega is what? Omega is this 4.5. 4.5 into 10 to the power 14 by k is 3 into 10 to the power 6. So this is coming as 1.5 into 10 to the power 8. So c by v will become 2, right? Because c is 3 into 10 to the power 8. So this will become 2 square. So that means it will become 4. So the correct answer will be 4. Answer for this will be 4. Fine. Let us move to the next question. Question number 23. A parallel beam of light traveling in air is incident on a convex spherical glass surface of radius. Okay, so there is a spherical surface like this. Okay, right? Radius of curvature is given 50. Refractive index is also given. Rays converge to a point at a distance x from the center of the curvature. Center of the curvature. Center will be here. So where it is going, the rays are parallel. So somewhere it will converge. So you can take as minus infinity, right? And apply this formula because refractive index mu1 is 1 here and mu2 value refractive index is given how much? 1.5. So mu2 by v minus mu1 by u is mu2 minus mu1 by r. Very important formula. Apply this mu2 1.5 by v minus mu1. U is infinity, so this time is 0, right? mu2 minus mu1, so 0.5. Radius of curvature is how much? Radius of curvature is 50 centimeter. 50. So what will be v from here? Calculate. So 1 by 2 will come, right? That means 100 will come. 100 into the 150 centimeter comes, correct? 100 into 1.5, 150 centimeters, right? So this is 150 centimeter. From here it is 150 centimeter, right? This is where the image is formed. But what about the distance from center? What is the center? So what is the distance center? Radius of curvature they have given, this is 50. So this is 50, so remaining must be 100. Correct. So the answer will be 100 centimeter. Okay, let us move next. 24. A circular disc has radius r1 and thickness t1. Another disc made of same material has radius r2, thickness t2. Same material means same density you have to take. Okay. The moment of inertia of both discs are same and r1 by r2 is 2. Then t1 by t2 is. So they have given the moment of inertia of first disc and second disc the same. Moment of inertia formula is what? Half for a disc, right? Half mr square. Half mr square. Half mr square. Remember these masses may be different, m1 r1 m2 r2, but we have to write in terms of density. So how can we write mass in terms of density? Half any we get cancelled. So mass you write in terms of density. Mass is density into volume. Density volume. Volume is what? Which is a disk. So area into thickness. Disk has got some thickness, so it is like a cylinder, right? Area of the base, area is pi r square. Pi into r1 square into thickness. Thickness of first one, let us say t1, and this is r1 cube, r1 square, right? Similarly, this is also going to be same. So pi r2 square into thickness t2 into r2 square. So from here pi rho get cancelled. So basically t1 into r1 power 4 is t2 into r2 power 4. So we need to calculate t1 by t2. So t1 by t2 is equal to r2 by r1 power 4. Substitute this value. What we have? We have r1 by r2. R2 by R1 will be what? R2 by R1 will be 1 by 2. 1 by 2 power 4, that means 1 by 16. So alpha will be 16 here, right? Then let us move next. Last question. Inductance of a coil with 10 to the power 4 turns is 10 millihenry and it is connected to a DC source of 10 volt with internal resistance of this. The energy density in the inductor when the current reaches 1 by E of the maximum. So what is this question? There is a coil. Inductor is there. L will be there, right? It has number of turns and blah blah. All these things is given. It is connected to a DC source with internal resistance. That means it is connected with a battery, okay, and some internal resistance. So R is also there and voltage. So this is a LR circuit, okay, right. Energy density in inductor when the current reaches to 1 by E of the maximum value. Current reaches to 1 by E of maximum value. So current becomes I max by E, right. What is the formula for current in this circuit? Current formula is what? I max 1 minus E power minus RT by L, correct. This formula we know already, we have idea of this formula, LR circuit, okay. Now what is the question is, when current becomes this, what is the energy density? Energy density in the inductor. In inductor, energy density, remember, energy density they are asking, not energy they are asking. Energy if they ask, that is half Li square. Energy density they are asking. Energy density. What is the formula for energy density? Energy density formula is what? Energy density half mu naught B square, right? This formula, remember. So we can think of using this formula. And what is magnetic field in the inductor? Inductor can be considered like a solenoid. So mu naught Ni, can we use that? And I think this should be taken as number of turns per unit length, correct. Then we can calculate that. So mu naught is what? Mu naught we should know 4 pi into 10 to the power minus 7. Number of turns per unit length is 10 to the power 4. And current is what? Current is I max by E. I max by E. What is I max? I max is V by R. You know that maximum current is V by R. What is the voltage of the battery? 10 volt, resistance is 10. So this is 10 by 10, 1. So this is 1. So this is 4 pi into 10 to the power minus 3 by E. So you got magnetic field. Now let us substitute that. Okay. So this we are going to substitute that. So 1 by 2 mu naught we have to substitute here. 4 pi into 10 to the power minus 7, right, into B square. Square of this 4 pi 2 times will come. So 4 pi square will be there, right, into 10 to the power minus 3 square 10 to the power minus 6 divided by E square. Check out this calculation. So 1 4 pi will get cancelled, right, and here what will happen? 4 pi by 2 pi will be there, 2 pi and 10 will come. So 20 pi by E square. Is this correct? Let us check that. So 20 pi by E square. So this factor what we are saying, that must be 20. Yes, alpha must be 20. That is the answer. So I hope you have understood the calculation. Maybe if any error may happen in calculation, but I hope we have done it with proper approach, right? Thank you for your attention. Then we'll see the next video.